Today we have Dr. Pat Kaiser joining us. Dr. Kaiser is the director of the Center for Native Grasslands Management here at UT. In this role, he leads a wide-ranging research program that reaches across numerous disciplines in an effort to understand these often overlooked native plants and the communities associated with them. He's also actively engaged in extension, sharing science outcomes with family farmers, other professionals, and conservationists. And today he is presenting Saving Our Planet One Steak at a Time. So thank you, Dr. Kaiser, for being here. And I'm going to go ahead and turn it over to you.
Great, thank you. Are you able to hear me okay, Alyssa?
Yes, loud and clear.
Okay, wonderful, wonderful. Well, thank you everybody for taking some time out of what I know are busy schedules to join us today, and want to share with you a project that at least I'm excited about, and hopefully will be one that does a lot of good for our whole One Health. So I do want to start off acknowledging some folks that were pretty critical in putting together, not maybe this presentation, but the proposal and the work that we're pursuing. And that's Doctors Chris Boyer, Cho, Jagadama, and Susan Scheck-Schneider and Forbes Walker. All of them have been very intimately involved in this since day one. And so I wanted to include them on that title slide and provide a much deserved acknowledgement. So if I can get these slides to advance. There we go. We're starting to move now. So grasslands, we'll start there since this is about grasslands. They're the largest land use on the terrestrial surface of the earth, 40% of the Earth's surface. Single largest land use, if we move down from the level of the globe to the United States, is in grass, and that figure there includes rangelands as well, but still forage lands. And from an agricultural production standpoint, these are dated numbers you see here, or dated number 77 billion in gate receipts to our farmers, but that's a 2017 figure. So that's now 7 years old. I need to update that. But regardless, relative to our other commodity production, and you can kind of see that across here, beef cattle is by far and away number one. And with some of the recent prices we're seeing for beef cattle, I expect that margin probably has increased. So whether you look at it globally or domestically, grass is a big deal and the products that come from it. And if we zero in just a little bit more and draw your attention to this map right here, that area outlined in blue corresponds basically to the tall fescue belt. And for those of you that are not familiar with that, that's the predominant forage grass in the eastern US. But this area is important by almost any measure. So it's large, number of states. If you measure it by producers or output or revenues, it's a big deal. So the fact that grasslands are dominant globally and in the United States as a whole is also true for our part of the world, the tall fescue belt. Well, speaking of grass and speaking of beef, there's another side to this story, and most of y'all have heard a lot about climate change in the past decade, one way or another, and greenhouse gases. And so this graphic that you see here is drawn from a fairly recent assessment by EPA, in which they tried to figure out where all the greenhouse gases in the United States come from. And what we can see is our friend agriculture is represented here in the, I guess, what are these, the top 6 sources at coming in at 10%. So let's drill a little further into that. This is the same report. And what they've done here is that they're showing you more or less that same set of data that says about 10% is drawn from agriculture. Everything else accounts for all the other. But if you break apart that 9.6% that is agriculture into these categories that they used right here, what you can see, and it couldn't even fit on the chart, is that what we call soil management accounts for 345 billion tons, whereas if we drop down to enteric fermentation, and that's our friends the cattle, we're down to about 180. So if you were to add up all of these bars, what you'd find is that there are 629 million metric tons, and 180 is the amount that's coming directly from cattle. that's a little bit simplistic. There's some other things at play here that I won't take the time to dive into today. But what I wanted you to see is that therefore about 28% of the agricultural footprint is coming directly from cattle. But if we break that back down to that 9.6% total of all greenhouse gases that agriculture accounts for, this 180 million metric tons is only 2.74% of that total. And I do want to point out for any of y'all that are big on climate related issues, these figures here are CO2 equivalents, not CO2. So that takes into account methane and nitrous oxide and all the rest. So what we have here is that cattle do contribute to this footprint. The point is, depending on how you want to measure and how you want to parse some of this out up here, it's not a huge part, but regardless, this conversation has gotten the attention of the major cattle enterprises in the United States. So U.S. Dairy, which represents all of our dairy industry, JBS Foods, the #1 beef and poultry packing company on the planet. And as far as within the United States, we often think of Tyson as chicken, but they're really the #1 beef packer in the United States, not globally. And of course, National Cattlemen's, which represents most of our cattle industry, the trade group. What I want you to see here is that all these entities very recently, 2020, 2021, and the other three also 2021, all made commitments to achieve carbon neutrality, or another term for it is net zero greenhouse gases. And they've got various time frames here, 2050, 2040. But the point is, this conversation has gotten their attention, and they have made these assertions and these commitments of where they're trying to go. So whether that 2.78% or 28% is a big deal or not a big deal, it certainly has industry's attention. And a while back, when I was preparing a very similar presentation, this popped up on my news feed on the desktop from Microsoft. And so not only is this something that industry is paying attention to, but I think the general public is paying attention to. And some of this stuff, I kind of had to chuckle at this thing. 2 years left to avoid global disaster. Pretty serious, right? And we probably won't make it. So I think that's pretty dramatic, but the reason I put that in there again is to stress that it seems that there are voices out there that are very, very concerned about what's going on. So let's go back to grasslands. We already said that grasslands are the biggest terrestrial land use on the planet, and that holds true in the United States as a whole and is extremely important in the tall fescue belt as well. But the other side of the story on grasses is they represent a third of the terrestrial carbon stocks and are the single largest carbon stock on the planet. Within our temperate part of the world, where Tennessee and the tall fescue belt fall, our grasslands, again, have a greater carbon pool than our forests. Forests are very important, and the size difference here isn't huge, but the point is that grasslands, to me, I think are often overlooked and are a very important carbon sink. One other real important thing, and California learned this the hard way a few years ago, they bought a bunch of carbon credits from forests in that state, which subsequently caught on fire and burned up, and all the carbon went right back in the atmosphere. The neat thing about grasslands is you can burn them all you want, but the carbon, about 95% of it, remains underground in the roots. And in fact, the small amount of carbon that you're burning off the surface actually stimulates the growth of these grasses to where they produce even more carbon, at least in the short term, underground. And of course, long term, it does not decrease the carbon pools. So again, a very important carbon pool. And better still is there's a lot of research out there that indicates that these grasslands and their relationship to carbon storage are responsive to management. And Teague et al., who from out of Texas Tech, I believe, recently retired, but Dr. Teague and his team have done a whole bunch of work in this area. And their conclusion is grazing ruminants actually sequester more greenhouse gases than they produce. And so again, grasslands and particularly grazed grasslands can be a very valuable tool for carbon sequestration. So here's a model that Teague and his colleagues put together. And this is a little busy, so I'll walk you through it. But what I'm going to show you is 5 scenarios. Here's the first 2 scenarios. So scenario 1 is situation normal. Scenario 2 is we get rid of half the beef cattle in the United States, just sell them to Argentina or get rid of them somewhere. And so what this does is you can see the green bar represents livestock production contribution to greenhouse gases. And we've gotten rid of half the livestock. So the size of the green bar is now 1/2 of what it was in scenario 1. Not a big deal, really, when you look at that. So here's some other scenarios that they model, and I'll walk you through these. So in each one of these cases, we're not getting rid of any cattle. What we're doing is we are changing the grazing management practice, and I'm just going to use some shorthand and call it improved grazing management. So the scenario 3 is 25% of this regenerative, adaptive, or improved grazing management is applied. 50% of the cattle are managed this way, and in this case, 100%. And so based on their fairly extensive data, if we can just simply do a better job of grass management, and this gets back to this responsive to management idea, we can actually wind up reducing the part of the green up here and increasing a lot that's actually going into the ground. Now, granted, that's a model, but this is a huge question with a huge implications and a huge footprint. And so at some level, we're going to have to rely on models. But Teague and his group are not the only ones to have come to some of these conclusions. So here's a fairly recent paper by Conant and their associates, and this is their conclusion. Improved grazing management, we just talked about that, improved fertilization management, legumes, improved grass species, etc., all will contribute to increased soil C. And by the way, this is one of our colleagues here from UT, Dr. Jagadama and Dr. Roundtree up at Michigan State, who's, again, done a huge amount of work in this arena. But their conclusion was, again, this should sound familiar, proper grazing management. And for me, as a native grass guy, particularly like this one, adoption of highly productive grass species will promote increasing C input. So there is clearly emerging science that suggests that grasslands under the correct management can be a huge boon to this whole greenhouse gas game. And what all this comes down to, as you might have imagined, is roots. And so what we're really trying to do with our improved grazing management is develop roots. So the name of the game in grasslands and carbon storage is this stuff you're looking at right here. And that's where the carbon comes from, and that's where, in some cases, the carbon remains. So we're all about roots, and these roots contribute. This is from the Dust Bowl right here, and I continue to show this picture because I've been told it's worth 1,000 words, and this one might be worth 10,000 words, but that's during the Dust Bowl, and there's some deep-rooted big blue stem holding the world together, or at least about 30 square feet of the world that was left behind from the plow. But if we can get these deep roots in the ground through good grazing management, good fertility management, appropriate species, which includes some of these deep-rooted natives, we can do a world of good for not only carbon sequestration, but improve soil health. And so we put together this proposal, what we refer to as a Grasslands Partnership. And what it's really about is improving grassland stewardship. And so what we know is that if I can grow more grass, as I've just demonstrated, healthier pastures and soil, more grass means better buffer against drought. And newsflash, none of us know when the next drought's going to be. The good Lord knows, but we don't. And but what we do know is there will be a next drought. And so we need to be prepared for it. And of course, better grass means that you're more profitable because you're not purchasing feed. And part of our vision for this project is to ensure that our producers, not just in Tennessee, but across the fescue belt, are well positioned to access the marketplace of the future, where there may be some premiums or even some requirements around so-called, I'll call them green steers or green animals. So ones that are carbon friendly. So we put together this partnership. There's about 30 partners. I'm not going to read them all to you or describe them all to you, but just I wanted to acknowledge that this isn't just Pat Kaiser. It's not just Pat Kaiser plus a few folks here at UT. It is a host of people from other land grants, conservation entities, industry, some beef and grassland associated trade associations, some various agencies. And so it's a huge undertaking across 9 states and involves a $30 million budget from USDA. So we got to give a shout out to USDA for their support as well. So under this partnership, I've mentioned the importance of more grass for a lot of things. I want to pause for a minute and talk about how that affects our net income. We know we can affect carbon and we know we can affect soil health, but let me address the income side of the ledger, the business case. And so this is a courtesy of Ed Rayburn, who again recently retired up at West Virginia University, but this is based on sort of a hypothetical 90-acre farm, which he actually had, and this is what sort of caused him to frame it this way. But as you continue to put more cows on that farm, your number of calves that are produced will go up, and the number of calves goes up means the more sales you have, and so your gross income goes up. And unfortunately, a lot of our producers, I think anyway, have this mentality is if I could squeeze a few more cows onto my farm, I'll make a little more money. Well, certainly you can increase your gross income, but you cannot spend gross income down at the store or for your kids' college tuition or anything else. What you can spend is net income. And what you see on that net income curve is something very different from the gross income curve. And what we see is we hit our peak income way back here at about 25 head. And that as we continue to add cows to this farm, our net income goes down. The reason for that is our expenses are going up. Our profitability is being impacted by having to purchase a bunch of supplemental feed to make up for the lack of grass that we see when we wind up here at these really high stocking rates. At these lower stocking rates over here, we actually are making a lot better money. Well, the beauty of this is, if you recall those last few slides I showed you about improved carbon storage, that's being driven by better grass management. And that better grass management means going from 40 head on 90 acres back to about 25. So not only do I do a better job of carbon storage because I have more grass, I do a better job of soil health improvement because I have more grass. And here I'm doing a better job of being in business because I have more grass. And you know, a profitable farm, I don't want this very, very simple point to be lost on you, remain farms. Farms that are over here where you have very, very low net returns tend to wind up being strip malls and subdivisions. And it's probably worth pointing out that the state of Tennessee, a report recently came out, many of you all may have seen it, led the nation in lost farmland to the tune, I believe I'm correct in saying, 2 million acres, much of which was in grass, hay and pasture ground. And so this matters. So more grass is important. So let's talk about this more grass thing. This is a brand new report that just came out courtesy of some folks up at Cornell University there in New York. So in 1992, you see a GIS layer here, and you may recognize some of these features. Here's Chesapeake Bay in Virginia, West Virginia. And the green, you might have guessed, is grass. And here's a little further south along the Atlantic coast, and you can kind of make out the Carolinas, Georgia. There's the Smoky Mountains, and Knoxville is probably somewhere right about here. And we see middle and west Tennessee out this way. So you can kind of make out where the grass was in 1992. By the time 2021 rolled around, what would that be, 30 years later? Look how much grass we've lost. There's a whole lot more white on both these images than there was in 1992. So grass that is not valued, perhaps because of carbon or because of the profits that come from raising beef cattle, has a tendency to stop being grass. It becomes forest, it becomes row crops, or it becomes strip malls. But in any case, it stops being grass and we lose the many benefits of that grass. So I've talked a little bit about the economics, the soil health, and the carbon. Let me talk a little bit more as we kind of go across that spectrum of one, health, to another important aspect of health, and that's biodiversity. So one of the outcomes of losing all that grass recently as well as historically is that we've lost a lot of our grassland related wildlife. So here's our friend, the northern bobwhite. what most of us call a bobwhite quail or just simply a quail. This is some data from the U.S. Fish and Wildlife Service. And what this shows is from a nationwide survey that's been conducted since 1966, every single spring on hundreds of routes that are surveyed early each morning in the spring. And they do this for all bird species. This isn't just for northern bobwhite. But in any case, what they've done is they've analyzed those trends for this particular species over that particular time frame. And anywhere that is red on this map is a declining trend, a fairly substantial declining trend. The sort of brownish colors are also declining trends, and the blue is the only place that is positive. And what you can see is for the vast majority of the species range, including those places I just showed you in this part of the world here, where we're losing grasslands, these trends are negative. These birds are disappearing. In fact, about 86% of the population that was present in the late 60s is no longer there. In other words, we've only got about 14% of our quail population left that we used to have. And I could show you several more charts like this for several other grassland associated birds, and the charts would all look very, very similar. In other words, it's an ugly story for this group of species. However, there's some good news, and I want to share with you some work from one of my PhD students, Doug Mitchell. So Doug's working on a telemetry project up in Kentucky. He's finished his field work, just working now on his analyses. But this is a study area, a place called the Bluegrass Army Depot near Richmond, Kentucky. And all these little dots you see are the locations of radio collared northern bobwhite quail and where they were located. And what you can see is there's a whole lot of these locations in this area here outlined in green, which happens to be our native grasses. Over here is traditionally managed tall fescue pastures. And what you can see is there are almost no, I can make out a couple here, one there, 3 or 4 there. Almost none of these quail bothered to cross this road to go over here. They remained in this area. And this area, of course, is native grass pasture. And some analyses that he has just wrapped up on very recently, that this is actually not drawn from the telemetry, but from some surveys, show that the occupancy rate, and so occupancy, for those of y'all not familiar with that idea, is simply the probability that if you went to a particular spot in the field, you would encounter a northern bobwhite. So in this case, 1 means there's a 100% chance if you went to that field, there would always be a northern bobwhite calling. And so what you can see is that in our native pastures, we had about an 85% occupancy. So 85% of the time in a native grass pasture, you're going to hear a quail calling, which is about 3.5 times greater than it is in these other 3 categories, including the ungrazed native grass. And so what this study has shown us is, in terms of One Health, we can do a good job of improved grassland stewardship, a job that increases soil carbon storage, a job that increases soil health, revenues to the farmer, but also allows us to produce these grassland birds. So that's part of the vision there. Another study looking at some other grassland birds, these are grasshopper sparrow and field sparrow. And this is a study Dr. Kyle Brazel finished up several years ago as part of his PhD dissertation done right here in East Tennessee. But he surveyed a bunch of fescue pastures and native grass pastures. And what we see is the total number of fledgling produced per field was about 4 times greater in the native grasses than it was in the fescue. So kind of reminiscent of that story we just told about northern bobwhite. But when we break these native grass pastures up into 2 categories, ones that were grazed continuously, but not too severely, and those that were grazed much more heavily, much shorter grass, what we see is that relative to the fescue, it's actually a 6-fold improvement. On the other hand, it's worth noting that if you look at the number of these grassland birds in a tall fescue pasture relative to a heavily grazed native grass pasture, it's really not that big an improvement. And for those of y'all that are more interested in some of the details on the wildlife, this is driven by habitat selection. not nest survival or clutch size. So in other words, here, clutches had the same number of eggs as they did here. Nest survival was about the same here as it was there. The difference is they chose to nest here much more frequently. They wanted to be here, just like the quail wanted to be in the native grass pastures. And so again, we see that same pattern. So we can have a healthier environment in terms of biodiversity by having better grass, which in this case would include some of these native grasses. And by the way, these species are like the northern bobwhite, particularly grasshopper sparrow, in pretty serious trouble in terms of population declines. So I've talked about disturbance, and that last slide should have brought home the importance of grazing as part of the story. It's not just that we have the right grass, but we have to have the right disturbance for that grass. And so from about the Central Plains, about Topeka, Kansas, Tulsa, Oklahoma east, we have about 35 inches of rainfall to where we are now, where we start to crowd 60 inches in other parts of the Southeast. And this is what these grasslands in the eastern half of the continent look like in the absence of disturbance. You guessed it, without fire and without herbivory, our grasslands grow up into forests, and a whole lot of the forests we have in the eastern United States today were once upon a time grasslands that had the appropriate disturbance. So I mentioned fire, and anywhere on this planet where there are grasslands, particularly warm season grasslands like we have in the eastern US, fire is a real natural part of a healthy grassland. It makes all kinds of contributions, important contributions. But North American grasslands, this is not the complete story. And for those of you that come out of the conservation community, there was a fella running around back in the 30s and 40s and 50s named Aldo Leopold. And he was very influential in framing a lot of the philosophy around conservation. And he made the observation that the tools that, and y'all have to remember in the 1930s, we had tremendous soil erosion. We had the Dust Bowl. We had species disappearing right and left from overharvest and degradation of habitat. And he made the case that if we wanted to restore the quality of habitat, restore these disappearing wildlife populations, things like wood ducks and wild turkeys and deer and pronghorn antelope and on the list goes, we would have to use similar tools that were used to break down the habitat. In other words, the axe, the plow, the fire. And a lot of people in the conservation community don't want to hear that word. But the reality is, he had the foresight to see that a cow and the herbivory associated with that cow was very important. And if we again think about North American grasslands, guess what, folks? It's these folks right here in combination with fire that regulated grasslands, including right here in East Tennessee, all the way out into Kansas and Oklahoma, where this picture was taken. And so I kind of got it that the 50 million bison could not have been wrong. And what's also interesting is the number of cattle that we currently have where we used to have those 50 million bison is, guess what, about 50 million head. And what's also interesting is some research coming out of Oklahoma State points out to us that the kind of disturbance that these bison make is not all that different than cattle or vice versa with the right kind of management. And so what we need to know is a healthy grassland in eastern North America almost by necessity has to be a grazed grassland. Get rid of the grazers. We get rid of the economic incentive for those grasslands. We get rid of much of the carbon storage. We get rid of much of the wildlife habitat benefit. So these are an integral part of a healthy grassland and need to be part of the picture. Now, one other thing we're doing here in our project that unfortunately doesn't allow the opportunity for cattle or disturbance is some high diversity field buffers. Now, we've known for years that field buffers are great for improving water quality, keeping nutrients, pesticides, and soil in place. They can also store a lot of soil organic carbon because annual row crops aren't that good at that, whereas perennial crops do a really good job of it. And so our goal here is not just to put any old field border in, but these high diversity, perennial native plant field buffers. And so these are going to be 5 to 10 species of native plants, grasses, and as you can see here, some forbs that are valuable to pollinators. And so this is, again, part of the biodiversity component of our project, and how this contributes again to One Health, a healthy environment. Again, not just soil carbon, but also pollinators. And by the way, something like 60 to 70% of our food crops, things that we eat every day that perhaps you've already eaten today, require pollination. And so it's not just a matter of protecting the biodiversity, it's protecting the food on your table. And I've already talked about these at-risk birds, but again, there's past research that Tennessee was involved in several years back that demonstrated that these field buffers could be disproportionately valuable to these at-risk bird species just with a little strip along the edge of either a cotton or soybean field. So in the title, we talked about steak, and I want to give you your steak, and it's dinner time for those of us in the Eastern time zone. So you might have your mind on food right now. So let's talk a little bit about the steak side of this. So we've talked about One Health from the standpoint of our climate, our carbon, our soils, our pocketbooks, our disappearing wildlife, disappearing grasslands, our pollinators. But what about your table? Well, let's think about this. By 2050, it has been forecast that the global population will be up to really close to 10 billion human beings. And it's estimated that we will have to increase food production by 70%. That's 70% over where we are today to achieve the amount of food production we need to feed 10 billion people. And just in the next decade, so never mind 2050, it's estimated that the population increase will require that we produce 14% more meat for human diet consumption. And so we think about that from a beef production standpoint, we're talking about 6%. And I'm going to take just a minor deviation here because I think I got a minute or two. We hear a lot about the negative influence of beef in the Amazon from cleared forests. I think here in the eastern United States, where we have a historic legacy of grasslands with herbivores that are essential to a healthy grassland, we actually need these cattle. And so if we can increase our beef production here in the resilient temperate world, that can take some of the pressure also off the Brazilian rainforest or other more sensitive environments. But the point is, we got to figure out a way as a society to produce more food in the coming years. And something that's also worth pointing out, red meat, doesn't that just make you hungry right there? Does that not look good, y'all? Some of y'all might be vegans or vegetarians and you're already mad at me, but I believe I could eat that. But anyway, these animal source foods provide some really important nutrients, and dietary researchers have shown that for pregnant women and young children, this is particularly important. Another thing that we've learned about red meat in our diet is that the bioavailability of a lot of these nutrients is much better than it is for plant or some of the new synthetic meats that people are producing. And there's some real important things, including dietary protein, folks. We got to have protein to function as organisms, and some really important nutrients there that have to be part of a healthy diet. And here's something that really ought to get your attention. We talk about producing all this additional food going forward. Half the child deaths, I think this qualifies for One Health right here. If nothing else qualifies for One Health that I've said today, if half of the child deaths globally are a result of malnutrition, we got a problem that we ought to solve. And not only does it result in death of children who are malnourished, but there's long-term implications from growing up without adequate nutrition that impact a society for really most of their generation. And these meat-based proteins could solve a lot of the world's nutrient deficiencies. And this is particularly important. Folks, we got plenty of protein on our table in the United States, but much of the world cannot say that. And so we can produce that beef in a way that benefits our carbon storage, our soil health, our grassland birds, our pollinators, and still keep farms and feed people who really need healthful foods. So back to the Grasslands Partnership itself, what this is all about is we've got about 300,000 beef cattle farmers in the Fescue Belt. And there are some emerging markets, or so it's forecast to be, around carbon and ecosystem services. And those markets have the potential to incentivize improved grassland stewardship. So I can keep a father and a son on a generational farm for years to come and keep it from becoming a strip mall and provide many of these benefits to this whole One Health concept. So I'll wrap it up with this. I'm a researcher, and part of my job is to hustle money. And so I've gone to USDA and several other federal agencies and asked for $500 million for a global moonshot to change the way we produce food. And what I was able to tell them is that we need to identify a technology that produces high quality protein from solar energy that is locked in human and edible plants. I dare you to try to eat that grass right there, folks. And better still, a technology that produces soil replenishing organic fertilizer and, if possible, self-replicates. I don't know how in the world we're going to come up with that, but if they give me $500 million, I'm confident I can find that solution for them. So with that, Alyssa, I am through the presentation, and if I left myself some time, and I see that I have, I'd be happy to try to respond to some questions.
Thank you very much. That was great. Does anyone have a question for Dr. Kaiser? You can put it in the chat, or you should, let me make sure. Yeah, you should be able to unmute yourselves as well if you'd like to ask in person. I'll just give everyone a second to formulate their question. Oh, here we've got one in the chat. How would your numbers and qualities differ on grassland managed for milk herds instead of beef?
Well, I haven't really given that a lot of thought, but what strikes me offhand is that on grasslands managed for milk production, we still have a lot of the same challenges as optimizing grass production, which optimizes animal nutrition, which optimizes milk production. So my speculation would be that the arguments would be really very similar in terms of what we're trying to produce and what the outcomes are likely to be. Other questions? While y'all are pondering that, I guess the thing to me that's kind of exciting about this is I've heard for years that beef cattle are going to destroy the world, so to speak. And, you know, you look at this again from a One Health perspective, I think it's kind of exciting to see how we can connect responsible stewardship to a tremendous suite of outcomes that benefit people, human beings, very, very widely. I mean, some of this beef could wind up on a table and somewhere where human nutrition is really at risk, but by the same token, we can produce more bobwhite quail. So I just think it's kind of neat to see that range of outcomes that can come from something that a lot of folks have thought of as a great big negative.
Yeah, I'll just say something real quick anecdotally since we've got time. But so I met Dr. Kaiser when I was working for the National Bobwhite Conservation Initiative before One Health. And then when I started working for the One Health Initiative, I had not heard that term before, but I realized I had this framework of understanding for it already through my exposure to this like grassland restoration and quail conservation work. There's a lot of overlap there. It's a great One Health topic. So, okay, since I've been talking, we've gotten some questions in the chat. One of them, how might this be applied to a silvopasturing farming option?
I think in a silvopasture environment, I think it's even more exciting than this. And two reasons I say that. One is that those trees provide some additional benefits, so they can be a supplemental crop. Let's say you grow pecans, which I know we don't grow a lot of here in East Tennessee, but walnuts, any kind of tree nut that has a place in the market. Or it could be lumber. Some tree species actually can be used for forage for cattle. So there's several possible benefits from the trees themselves. But the other issue with the trees is they provide shade for the cattle, which is an important part of their health. And if we accept the models that say we're all going to burn up in the next few years, shade's going to come at a premium. But also those tree roots are socking even more carbon into the ground. And then one last point to me that again, I think is kind of neat about it As I mentioned, we got a heritage and a legacy of grasslands across the eastern United States. The best evidence we have is not that we had vast prairies in Tennessee, although we did, multi-million acre prairies out in West Tennessee. But what we had was a mixture of trees and grass that we now call a silvopasture, or we would have called a savanna or a woodland back in the day. And those were really extensive and is probably the closest thing we can get to the quote, natural or original condition of the eastern U.S. And so when you're creating a silvopasture, you are really moving into the future by going back in time. And so I think a lot of the benefits that we talk about here are going to still be there and maybe even be there more strongly in a silvopasture.
Some more questions from the chat. Someone says that they set up at a local farmers market in July and talked to people about Beef Month. They would love to get some resources or handouts, more info about this that they could hand out to the public. Is there a website with these types of resources?
Yeah, let me mention 3 places where I think you can find what you're looking for. One of them is UTbeef I guess it would be com, I think. But if you just type in UT Beef, it's going to come up. But that's our UT Beef and Forage Center. There's a lot of resources there. You can go to our Center for Native Grasslands webpage at nativegrasslands.utk. You can also look at the National Cattlemen's Beef Association. They probably have some literature in this direction as well that you may want to look at.
All right, I'll put those links in the chat in a second. Where are you on the Grasslands Partnership grant and how is it going?
Yeah, so we got awarded last September, and during the course of the fall, took care of a lot of the administration for our subcontractors to these 11 other land grant universities and several others as well. And we've been developing a lot of the platform to roll out to producers. And we are, in fact, at that stage. We're trying to get a couple hundred farmers across our 9 states to enroll. And we have started that process and, of course, are seeing enrollments and hope to have all of our producers enrolled by early to midsummer.
Do you have thoughts on which species of grass we can focus on in East Tennessee to support that native biodiversity, but that are also highly competitive as a source of cattle nutrition?
Yeah, so the native grasses that we have focused on, there's about 1,000 species of native grasses in North America, and we don't pay attention to the vast majority of them for a variety of reasons. They're not really important historically or ecologically. I guess everything's important ecologically, all the good Lord's critters, but including the grasses. But the grasses that dominated the North American grasslands were things like big bluestem, Indian grass, in wet sites, eastern gamagrass, and also in wet sites, switchgrass. And those 4 species, along with a couple of others, are the ones that our research and management has focused on, and that are very productive in terms of rates of cattle gain and stocking rates and economic returns. So those are the ones that we have focused on the most. I see the word biodiversity in that question, and so one of the things that we would plant if we were interested in not just beef production, but beef plus biodiversity would be a blend of big bluestem, Indian grass, little bluestem, and perhaps even throw some side oats, grama in there to have a little more diversity.
Also, are you aware of any studies or practical trials on the commercial potential of raising bison in East Tennessee?
I have not been involved in any projects with bison. One of the things, I think they're one of the coolest animals on earth. I love the crazy looking things. But one of the challenges is that they take longer to reach maturity and produce fewer calves than domesticated beef cattle. And I suppose at some point with maybe some animal breeding, we could get them to be more productive, but that may sort of defeat some of the idea of working with a native animal. So I think that the infrastructure is also going to be more expensive. These are some big, tough animals, and the kind of fences that we can get away with old tame Angus, relatively tame, are two different things. And so you're going to have to, pardon the pun, but beef up your infrastructure and accept a little lower production. Now, if you can get more pounds, or excuse me, more dollars per pound, it may just net out for you. It's going to be a niche market, but a lot of people are attracted to it. There's some health benefits, it's thought, to the meat. So I think, like so many ag enterprises, it's going to be tight margins, but not out of the question if you're willing to take on that challenge and stick with it.
All right. Any more questions for Dr. Kaiser? That's all we've currently got in the chat. Still have plenty of time. Don't be shy. Oh, okay. We have one coming in. Okay, what is the best a small producer can do as far as pasture management?
Well, I suppose that depends on a whole lot of odds and ends, but in a nutshell, to me, making sure that you leave enough grass behind for the grass. A wise man once told me it takes grass to grow grass. And so if you nub that grass down where you have very little leaf surface area, you're going to have very weak plants that won't survive drought well, won't survive stress well, will allow lots of weeds to take over the pasture, won't sequester a lot of carbon, and certainly won't provide habitat for much wildlife. So the one piece of guidance I'd give you is leave some grass behind for the grass. There's an old adage, take half and leave half. So those are sort of the simplest way I could put that. And that applies whether you got 1,000 acres of pasture or you got 3 acres of pasture.
Okay, another question in the chat. What are the outcomes of the Smithsonian Partnership project on planting pollinator plants in pastures? That's a lot of alliteration there.
Yeah, there you go. Well, so for those of y'all aren't familiar with this, I've been asked a lot of questions in going back 5 or 10 years ago about, can we create more diversity in these native grass pastures? And so I finally took the hint and was able to find some funding and do some research in that area. And a few things that we've learned that really are, with one exception, overwhelmingly positive, is that these native forbs so these wildflowers basically that produce these beautiful flowers are very much preferred by a lot of the pollinator species that are at risk and are very important for pollinating a lot of our crops. So those have really high protein levels or relatively high protein levels. They maintain those protein levels through the grazing season. They have very low fiber levels, which means cattle can digest them much more easily and have higher intake on them. So we've learned that. We've learned that there are a suite of species that we can reliably establish and tend to maintain themselves in native grass pastures. Another benefit that we found that I hate to say this, but it surprised me, is we actually produced more gain, more beef per acre with these diversified pastures than just with the grass pastures. And so we haven't had the opportunity for our economists, and we always work closely with our ag economists to try to understand the business side of all of this. But if I'm producing more beef per acre, if my costs haven't gone up, then I'm making more money, and therefore I'm more liable to remain a farm. There's a pretty good upfront cost of establishing these things, but the long and the short of it is other than that cost, there's not a lot of downside. It's pretty. It improves pollinator habitat. We think it improves grassland bird habitat, and apparently it improves beef production. The one I mentioned at the outset of that response, that there is one downside to all this, and traditionally we manage our pastures with some very benign, non-toxic herbicides. They just basically mess with the plant's growth pattern. They don't harm humans or animals. But these herbicides are what we've relied on in recent years to keep the weed pressure down in our pastures. And the problem is those herbicides tend to kill broadleaf weeds. That's, after all, what they're designed for. But what we're seeing is that we get an increase in, because we're not using those herbicides, and we tend to get an increase in a lot of these sort of unpleasant ag weeds that people don't want to see in their pastures. And so we're trying to resolve that. Dr. Eric Basangwa, who is a postdoc who works with me, is working with a couple of grad students to implement a research project to explore just how tolerant some of these native forbs might be to some commonly used pasture herbicides. So we got a certain amount of hope from a pilot study that we can actually get away with some weed control work, which I think would go a long way to helping a lot of farm operators feel more comfortable putting some of these native forbs out into these native grass pastures. So on the whole, it's really looking like a very positive story at this point in any case.
All right, anybody else? We're nearing 1 o'clock, but we'd have time for another question or two if anyone has one.
Well, Alyssa, while we wait, I see a few of the people that are signed on. I wanted to acknowledge Justin McKinney, who's our director of our research station up at Greenville, Tennessee, where a lot of this research I've been describing has been hosted and is being hosted. And somewhere I saw Trey Clark, who's the research associate up there, who we can talk about doing this research, but it's folks like Trey that really carry the weight for us. And I see Dr. Forbes Walker signed on, and as you saw from my title slide, he's one of the co-investigators and mafia members on this whole operation. And so appreciate all his support and contribution from day one on all this crazy stuff that we're doing. So I thought I'd give a shout out to some of these folks and appreciate their contributions.
Dr. Kaiser, I want to thank you. I am going to be listening to the recording of this because I unfortunately was in class during this time, but I really appreciate you taking the time out to share everything that you're doing. That's awesome.
You bet. Thank you, Deb. Thank you. Appreciate the opportunity.